Okay, good morning, everybody. We're going to go ahead and get started. Thank you for joining us for the July edition of our ongoing data exchange webinar series. This month's is titled How Every Role in Your Shop Floor Benefits from Machine Monitoring. And we're going to be going over how some of the features inside of Scytec DataXchange machine monitoring can be applied to just about every employment level that you guys have out on your shop floor. What I'm going to be going over this morning is not an exhaustive list by any means. It's just kind of meant to, give you guys a refresher on some of the data exchange features. And this is also not going to be necessarily a high-level data exchange webinar. We are going to be going over some kind of intermediate topics. So towards the end of this, I'm going to be going over some of the more kind of high-level data exchange features, but this is really meant for those who are current data exchange customers. And as usual, I'm going to be going over the order of events right off the bat. And what we're going to be discussing is how the data exchange features can be applied to operators, supervisors, and managers, as well as maintenance. And then we will be ending by discussing how data exchange features can be used by everybody. And then finally, I'm also going to be discussing the latest data exchange update and what is in that. And this webinar is going to be a little bit shorter than normal. We usually try to keep these around about a half hour to 45 minutes. This one's probably going to be around 20. So first up, I'd like to discuss the data exchange features that are specifically tailored for your shop floor operators. And the big one is the ODI, which stands for the Operator Data Interface, and it is designed to be used on the shop floor by operators. And if you look over there on the right, the Operator Data Interface is a supplemental application that is now available on all licensing levels for data exchange. And operators working inside of a cell can track the machine statuses of multiple pieces of shop floor equipment and other necessary metrics like work orders and good and scrap part counts. With the equipment overlay function, which is what you see over there on the right, there's 4 different pieces of equipment, including a welder, a laser, a saw, and a punch machine, and it is dictating certain things like the machine status, which for the welder is in an unknown downtime, some other reported metrics like the logged in data exchange user, the work order that is getting worked on, the part number that is getting worked on, the parts per hour plans, and the amount of good and scrap part counts that have been produced. However, the main focus of the operator data interface is for operators to be able to add downtime reasons that cannot automatically be collected from machines with the operator data interface tablet. So what we were looking at before on the last screen was the equipment overlay function, part of the ODI, but what you're seeing over there on the right-hand side is the downtime entering screen for the ODI. And there are many scenarios where a large block of time did not have an appropriate planned or unplanned downtime entered when it should have been. There are cases when a downtime needs to be entered and the start time set to an earlier time, or cases where previous stops need to be filled in after the machine has already gone back into cycle. The operator data interface provides the ability to modify the unknown downtimes that have previously occurred for these scenarios. So what you're looking at the image over there on the right-hand side is the downtime entering screen, which you can see over on the left-hand side. There is a long list of unplanned, planned downtimes, as well as work orders and part numbers, good and scrap part counts, and more. And then below that are the machines that were shown on that previous image in the last slide, including the laser machine. And if you look over there on the right, the laser machine has a box that is red, indicating that the current status is in a maintenance. So once the machine goes out of that maintenance status, it'll go back into in cycle, for example. That color red will change to green. And if you need to go and put that machine back into another unplanned or planned downtime, you can select one of the reasons there, like what we are looking at for unplanned downtimes include things like alarms, maintenance, no materials, programming, and more. You can also see there are options for a modified timestamp and note history that I'm going to be discussing in the next slide after this one. So there are 2 methods of classifying unknown downtime from the operator data interface tablet, both of which are controlled by permissions. The first method is to enter a planned or unplanned downtime and set the start time of the downtime to when the currently active unknown downtime began. The second method is to view a list of previous unknown downtimes and backfill each with the appropriate downtime reasons. And as I mentioned just previously, to be kind of aware of the modify timestamp and note history that I'm going to be discussing both in this current slide and the next slide. But the modify timestamp button has two possible options, current and previous, where you can modify previous downtimes, either the current one or the previous ones. And you can also view these modified downtimes with the modified data report. So next up, I'd like to be discussing the ODI notes. And while using the operator data interface screen, it may become necessary to record further detail regarding the current state of the machine. And you can do that with the notes function inside of the operator data interface. To do this, it is possible to capture the detail about what is going on by using the notes field. With this feature, the machine operator can leave detailed notes about what is currently going on with the machine, and to leave a note, the operator does not need to have the correct permissions. Notes can be entered at any time, even without changing the status of the equipment. And a good use case for this is if a machine operator is encountering a problem, the operator may want to display that on the RTV or trigger an email or text message. And to enter a note, select the equipment and the current status it is in, and then enter the note. Then press the Start Status button. The note left by the operator will then be stored in the database and displayed on the RTV if the RTV screen has been configured to display the equipment status notes. So next up, I'm going to be discussing how certain features in Scytec DataXchange are good for supervisors and managers to use. And what I'd like to start off with first is the parts per hour RTV view, and that is to calculate and display an ongoing target for good parts based on the operation time. Using operations time, it is possible to display the expected parts per hour for a specific part and machine combination. To start, operation times need to be assigned to the machine and part combination. Parts per hour has an RT view as well as a report version that you can download as well. And kind of piggybacking off of that, we have, this is something that just came out in our newest DataXchange release that came out this month of July 2026. And this is a new active work order view that displays information about each current work order and the associated operations and equipment in a card format. And this is a new view that is part of our RTV Designer that can now be found in Data Display. If you've been using DataXchange for a while, you may remember that the RTV Designer was originally found in the desktop configuration tool for DataXchange, and we've been moving a lot of the historically found features in that desktop configuration tool over to the online and mobile browser-based reporting tool Data Display. And each work order is displayed with a specific work order operation detail displayed underneath it for this new active work order view. And the color of each row indicates the state of a given operation. So green, the operation is currently active. If you look in that image over there in the left-hand corner for the work order LMP 1001, we have a Haas machine that is currently has 3 parts per hour that is dictated. And then underneath that, we have a LMP 2021, which has a color blue, which indicates that the operation is completed. And you can see that with the parts per hour dictating 7 parts, and that the parts per hour actual shows 7, meaning that it has fulfilled its parts per hour obligations. And then below that, we have the color yellow for that Haas machine, and that indicates that the operation is currently inactive and nobody is currently working on that work order. And the data that is reported in this new work order view, if you go from left to right, starting with the OP, which indicates the work order operation number, and then next to that, we have the equipment, which is the machine associated to the work order operation. And then below that, we have the parts per hour. And the defined target for the parts per hour for the work order operation, this can be specified when defining the work order operation set by ideal times or by the parts defaults. And then next to that, we have the parts per hour percentage, which details the percentage of parts made versus the target parts per hour. And then the parts per hour actual, which is the number of parts made. And then next to that, we have completed, which is the number of good parts completed, followed by remaining, which is the build quantity minus the good parts completed. Now, I'm going to have a little bit more on this new work order towards the end of this webinar, where I'm going to be detailing some of the other provisions in the newest DataXchange release and about why this work order is a good thing to have, even if you think that you can already get this kind of information from an MES system. Another good DataXchange feature for supervisors and managers is defining DataXchange reporting groups. And defining user groups in DataXchange can grant different employment levels access to certain charts, plants, and equipment, and more, depending on what supervisors want different employment levels to have access to. And some more features in DataXchange that I'm going to be covering for supervisors and managers. We also have the scrap Pareto chart, and this chart displays the amount of scrap parts and the percentage compared to the total amount of scrap parts over the time frame selected. And what you're looking at below is all of the different reasons for the scrap that's been created in a selected time frame in a chart. And the chart below shows, going from left to right, the biggest issues that are leading to these scrap parts out on a shop floor. And what is being detailed in this is showing from left to right that the biggest issue that you guys have in order of occurrence, going from gauge to non-conforming to dented parts, being the main culprits of the scrap part reasons. And some other features. More that I'm going to be discussing is managing and designing RTV screens, where managers and supervisors can design specific DataXchange dashboards for certain areas of employment that shows data meaningful to their job responsibilities. And you can do that with the RTV Designer. And the RTV Designer, as I said, historically was found in the desktop configuration tool for Scytec DataXchange. It has now moved its way over into data display. However, this is still a pre-release function, and you need to contact Scytec support if you'd like to get this turned on for designing your RTV dashboard screens. And then we also have the equipment summation list. And the equipment summation list is a newer real-time dashboard that we have for DataXchange, which displays the total amount of status time for each selected machine, as well as totals for part counts, numerical, custom variable values, and more. Next up, I'd like to discuss some of the features that are in DataXchange that are good for maintenance. And a specific one that I'd like to single out is the alarm RTV view. And this view for the RTV is broken down into 3 different charts, and the first being the alarm grid, which you can see up there in the top, that goes all the way from left to right. And that chart, which is the alarm grid, displays collected data from alarm codes recorded by machines, and it details the equipment name, the alarm type, the alarm code, the alarm description, the duration and quantity of the alarms, as well as some other metrics. And then below that, we also have alarm Pareto charts, which displays data collected from the alarm codes in a Pareto format by both time and by occurrence. So if you look over on the Pareto chart on the left, it'll show you the alarms by time. And then over there on the right, the different chart that you see there is showing the alarms by occurrence. Schedule planned downtimes. This function will allow the ability to schedule a one-time planned downtime for equipment in the future. And there is also a scheduled downtime report option as well. And this is a good tool to use for maintenance teams so that they can schedule maintenance in advance for production machines. And then finally, kind of rounding things out here for some of the DataXchange features is this is a section that details the DataXchange features that everyone can use. And I'd like to first start out with the timeline chart. And the timeline chart displays a stacked bar chart on a timeline showing the incremental statuses of the equipment over time. And the equipment can be selected by user groups, company groups, as well as just individual equipment. So the image that you see there is from the timeline chart, and it shows you all of the reported machine statuses over the time frame that is selected by the DataXchange user. And we have all the equipment going there from left to right, including a hard-edge machine, a Masura, a PLC, and more. And then also kind of piggybacking off of that is we have the summary chart. And the summary chart displays the percentage of time that each piece of equipment has been in each status for the time frame selected. And basically what the timeline chart shows you is everything that was presented before with the equipment status summary, but this is now grouped as percentages. And we can see that we have a Doosan machine that is selected there, showing that 52% of the time frame selected has been in a no material status, and you can see some of the other reported machine statuses in this chart, detailing things like tooling, no material, waiting for operators, alarms, brakes, blade changes, unknown downtimes, normal cycle statuses, and then also low and high override. So everything that you are looking at in this image can be detailed with that little graph over there on the right side. And then we also have saved and scheduled charts. And DataXchange has the ability to schedule charts and reports. Once you've done all the filtering, you can save that chart and have it scheduled to be sent to you as well as other dictated users and user groups on a recurring basis. And this is a good kind of automation related tool for if you guys have Gemba walks or production meetings every morning where you can get your necessary DataXchange charts, reports, and dashboards sent to you on a recurring basis so you can walk into these meetings well informed about what's going on. And then finally, for the end of this webinar, I'm going to be discussing the newest DataXchange update and kind of adding a little bit more to that active work order view that I talked about earlier. And the DataXchange Summer 2026 update saw new additions to the RTV Designer, including a parts per hour RTV view, as well as the active work order that I discussed, and the real-time lists and equipment cards making their way to the RTV Dashboard Designer inside of Data Display. And I mentioned earlier the work order view for tracking work orders in real time. And we also have the addition of German language now being supported by DataXchange. And as I mentioned earlier with the RTV Designer, it is a kind of pre-release feature for DataXchange, and that you need to reach out to Scytec support for more information on, the RTV Designer and Data Display, where we'll do a walkthrough with you about how to use it, how to design your dashboards, and then also to have it turn on in your Data Display account. And with each of the following subsequent DataXchange releases, you can expect to see more RTV views added to the RTV Designer in Data Display. So as I kind of discussed earlier with the active work orders view that has been added to Data Display, I'd like to kind of go over with some of the value that this provides for DataXchange users. And, as I talked about earlier, why this shows you a little bit more data than you would get from an MES system. And MES systems do not have the real-time data that DataXchange machine monitoring does. The DataXchange part counts that are displayed in the work order view shown are coming directly from shop floor equipment. And for most MES systems, an employee manually updates the number hourly or at the end of a shift, and this can lead to some discrepancies in the reporting.